Hi everyone, this is Mr. Lee. In this video, we're going to go over the kinematic equations. Now, in this video, we're not necessarily going to go over sample problems. That's going to be for a different one, but we are going to be introduced to the our first set of equations. All right, so to begin, it's important for us to know that acceleration is the change in velocity over a period of time, because the kinematic equations that we're about to go over is meant for an object experiencing constant acceleration. Okay, so a list of variables so far. Okay, so just a good reminder of what we're about to see. We have position as x, distance as d, displacement as delta x, speed, velocity of v, acceleration as a. So what I'm going to do now is I'm actually going to put a little star next to the variables that are vectors, because it's a good reminder. Okay, displacement is a vector, velocity is a vector, and acceleration is a vector. And what I'm going to do next is I'm going to highlight the formulas that will, or excuse me, the variables that will show up on our formula sheet. The first one is position. Then we have a combination of displacement. We have velocity, and we have acceleration. Okay, so you'll notice that the scalar versions of those variables will not be ones that we focus on. All right, now this giant screenshot is actually our formula sheet that we'll be using for this entire year. Okay, it's a 2-page document, and on the back of the document we have all of this. Okay, and we'll cover, I think we'll cover all of this by the end of the year. And to start us off, we have the first 3 formulas in your upper left-hand corner. Now, if you can't see it, that's a-okay. I've linked the document in the video, the descriptions, so you can see it there. But I'm about to zoom in those 3 formulas below. Okay, so on the left-hand side is the zoomed-in screenshot of those 3 formulas, and in my own handwriting, you'll see how I will be writing the formulas when we are in class. Okay, so just a couple of things I want to point out. In the formula sheet version, okay, they have subscripts here that tells us that it's directional, right? So this is v sub x, meaning this is the velocity in the x-axis. But here I have v sub f. So the reason why I do that is that this velocity vector here, this tells us, or we are looking at the final velocity. Here we have vxo, where once again we're looking in the same axis, the x-axis, but that O, or that 0, represents initial. Okay, so we can see that in my note there, that 0 represents initial. So in my version here, I don't have that additional subscript. I just have the 0 there for initial. Sometimes you might see me write initial as AI, but it's interchangeable. And we have A, and this A here does not have a subscript, and we have this T. Okay, so the reason why I went over the variables individually is because there is some multiplication involved, right? So this VO and this VF, these are both one variables, but that A is it represents acceleration, and we are multiplying that to the variable of time. So you can see here that in the very first line, we have a total of 3 different variables. Okay, we have VF, VO, A, and T, and only the acceleration and the time are being multiplied. So if you take a look below, same notes, same ideas, we have final position is equal to initial position plus V initial times time, right? And so the reason why I'm pointing this out is this is one of those parts of physics that many students they get confused at first, right? They want to multiply V times O times T, but I'm here to tell you that that O is a subscript, and that T is the only other variable. So here we are multiplying the 2 together, and then off on the right we have 1/2, which is a constant. Okay, it's just 0.5, and we have that A there for acceleration, and then we have that T. Now, this one is a very common mistake that students make, but this T, and only this T, is being squared. Okay, so that T and only that T is being squared. So if you take a look at this row here, we have 1, 2, 3, 4, 5 different variables where one of those variables is being squared. All right. The next line down, most of the time students don't really have a issue with this formula. The only thing I do want to point out is that this 2a times xf minus xo, right? Sometimes you'll see me write it as 2a times your displacement. Okay, and I use parentheses a lot to really separate, like visually, the things that I believe are the things that's important to point out that students sometimes miss. All right, there we go. Cool. So we have our 3 kinematic formulas there that we'll be using for the rest of the very first unit. All right, and that's it. I'll see you next time. Bye-bye.